on Friday, we did algebraic properties and algebraic proofs. Okay, today we are starting to get into geometric proofs, geometric properties that we will use for these geometric proofs. So the first thing we want to just review over what we talked about Friday. It's there up there at the top, the properties of equality. We talked about the addition property. We talked about the subtraction property, the multiplication property, the division property, the distributive property, substitution, reflexive, symmetric, and transitive. Those were all the ones that we discussed on Friday. Okay, all of these can be used, but the important part is those can only be used with equal signs, okay, not congruent signs. We're going to talk about properties of congruence in just a minute. And we did talk about a few of those on Friday, but we're going to talk about a few more. Okay, so when we do proofs, okay, the algebraic proofs like we did the other day, you have to support every step in your problem solving, okay? You cannot assume that I know anything when you're writing these proofs. So just because I say something is congruent, you cannot assume that I mean that I know that means equal. Okay, so what we're gonna have to do is justify every single statement that we. No. We're gonna be writing. All right, so we talked about some of these properties of congruence on Friday, but we're going to re-talk about them again today because we will be using them in some proofs for the next few days. So the reflexive property of congruence says that anything is congruent to itself, same size, same shape. So it says for any segment AB that we could write that segment AB is congruent to itself, segment AB. You have to make sure you put those bars above the A and the B because you're referring to an object, not an actual length or a number, okay? Congruent means same size and same shape. If they're both segments, they're the same shape. In order for them to be the same size, they have to have the same length. But if you're talking about this pen, it's congruent to itself. It's the same shape, it's the same size, okay? Same length, same exact shape. I could not say that this pen is congruent to this marker. Okay, they're not the same shape. They're not even the same size. But let's say they were the same size. I could say that they are equal to each other, but they're not congruent because they're not the same shape. Does that make sense? Could I say that a segment is congruent to an angle? No, they're not the same shape. Congruence is only for the same shapes. All right, and then the symmetric property of congruence. We also talked about this one on Friday. We could say that if segment AB is congruent to segment CD, the symmetric property says I can just change the order of those and say that segment CD is congruent to segment AB. The symmetric property doesn't change anything other than the order in which they are listed. We also talked about the transitive property on Friday. We're going to talk about it again. It is of congruence this time. So if segment AB is congruent to segment CD and segment CD is congruent to segment EF, then which two segments could we say are congruent? AB and EF, yes. So sometimes in these proofs that we're going to be doing, we're talking about congruency rather than equivalency. Even though a lot of the times the two properties, substitution and transitive, could be mixed, like you could call it substitution or you could call it transitive as long as it's three parts. However, transitive is not, substitution is not used for congruence. It's only used for equality. So we cannot ever use substitution as a reason if we're talking about things being congruent because it's not a property of congruence. The only properties of congruence are the reflective, the symmetric, and the transitive. Are we kind of okay? All right. Now, one of the definitions that we will use quite often in our proofs is the definition of congruence. Okay? And with the the definition of congruence. It can go either way. First of all, you can say that segment AB is congruent to segment CD. Okay, same size, same shape. If they are congruent, then what we are allowed to say is that their lengths are equal to each other. You notice the difference in how I wrote that? The first blank is segment AB is congruent to segment CD. It has the segment bar above it, and it also has that little squiggly above your equal sign, making it congruent. If I'm saying that their lengths are equal, I do not put a bar over the AB, and I do not put the squiggly over the equal sign, okay? This one refers to same size and same shape. This one is referring to the same length or same size, okay? Different meanings. It can also go the opposite direction. If I were to tell you that the length of segment AB, the length of segment AB is equal to the length of segment CD, then using the definition of congruence, you could say that segment AB is congruent to segment CD. So you can switch those around. Do you guys remember what it's called if I take my hypothesis and conclusion and switch them? Which statement was that? That was from the last quiz. One of the verses, converse or inverse? Converse. Inverse negates them, converse switches them. Okay, so a lot of these times when we talk about theorems, it'll say the converse of this is also true. That just means we switch the hypothesis and the conclusion. All right, then another definition that we can use in our proofs is called the definition of midpoint, okay? If we think about the definition of midpoint, the definition of midpoint says we can divide a segment into two congruent segments. So if M is the midpoint of AB, then we can say that AM, segment AM, is congruent to segment MB. Okay, definition of midpoint. It says we divide a segment into two congruent segments. Therefore, if I tell you that you have a midpoint, the next step in your proof would be to say, okay, well, tell me which two segments are congruent. And you'll get to see these proofs here in just a few minutes. Is everybody following along? Okay. A postulate that we have discussed before. The segment addition postulate says I can take two small segments. I can add them together and they will equal a larger segment. So what two segments could I add together to equal the big segment here? AB. So segment AB plus segment BC is equal to the whole segment AC. All right. Segment AB, this little one, plus segment BC, that little one, equals the entire thing AC. All right. Are we ready? Everybody got these written down? All right, flip your paper over. I know what's coming and I know how difficult this is. So, look at what we're given. What does it tell us? AC is equal to 12, yes? What did I tell you on your algebraic proofs? What is the very first statement always? The given. So fill that in. Whatever is given to you, that goes to statement 1. And the reason is because it's given. All right. You told me what was given was that AC was equal to 12. And the reason is because it's given. Now, what are we trying to prove? What does it say we're trying to prove? X equals 2. Okay. It didn't give me an equation though, did it? No. All right, so first of all, looking at our picture, remember, you cannot assume this proof is showing me how you get from the given to the proof, not missing a step. You cannot assume that I know anything. All right, I don't know anything about geometry, and this proof is going to lead me from one step to the other, filling in all of the blanks. So look at our picture. What am I given? What object am I given up in my picture? Segment, angle, rectangle, triangle, what am I given? What's drawn? A segment. Yeah, a line segment. What postulate did we just talk about on the bottom of the previous page? The very bottom. Segment addition postulate. All right, do you see in that picture 2 small segments that I could add to equal a larger segment? Yes, what 2 segments would add to equal that larger segment? Okay, so let's write that. AB plus BC would equal what? AC. What reason? What postulate did we just use?
Segment addition.
So our reason is going to be the segment addition postulate. I'm just going to abbreviate, okay? Usually I would abbreviate seg add post instead of writing the whole words, but since this is the first time we're doing this, I want to write that. How did I know I could add those 2 segments together? What reason? What postulate did we just refer to? Segment addition postulate. So you're proving to me your steps here. However, I need to get to x equals 12, right? Which means I need to get an equation in here somewhere. Okay. So let me ask you this. Looking at your picture, we're going from the statement AB plus BC equals AC. Let me write it up here. Do we know anything about segment AB? Look at your picture. It's what? It's 2x. So isn't there a property that says I can replace something with what it's equal to? Okay. Next question. What do we know about BC from our picture? It's x plus 6, yeah. And then what do we know about AC that was given to us? So I can replace AB with what it's equal to. I can replace BC with what it's equal to. And I can replace AC with what it's equal to based off of what property? Substitution, exactly. So I'm going to write this 2x plus x plus 6 equals 12, and that is the substitution property. And just a little thing. We talked about abbreviating substitution and subtraction the other day. If you're going to abbreviate substitution, it needs to be that. S-U-B-S-T. Okay, that's substitution. If you're going to abbreviate subtraction, it needs to be S-U-B-T. Okay, do you see the difference? If you just put S-U-B, I don't know which one you're talking about. You have to tell me a little bit more. Oops. Or you can just write the whole word. But if you're going to abbreviate, make sure you abbreviate with enough letters so that I can tell the difference between substitution and subtraction. Is everybody good? Okay. Now, following along with this equation, if I have 2x plus x plus 6 equals 12, what would you do next? If I wanted to solve this equation, what would you do next? Combine my like terms. What's 2x plus 1x? Okay. So guess what our next step's going to be? What's my next statement going to be? 3x plus 6 equals 12. Okay. Even though we combined our like terms, it's not addition because we didn't add on both sides. When they combine like terms, they call that the distributive property. I would be okay if you put combine like terms, but all of these books call that the distributive property, which I don't really like that. But we're going to go there anyway. We're going to say distributive. Again, if you want to put combined terms instead, that I'm okay with that, if that makes more sense to you. Okay. You can write combined terms instead of distributive, and I would give you credit for that. Is everybody okay so far? All right. Next, in my equation solving, what would I do? I'd subtract 6, and I'd end up with 3x equals 6. So guess what my next statement is? (3x equals 6), and what's the reason for this one? Subtraction, yep. And then what would I do? Divide both sides by 3, and I'd end up with x equals 2. Isn't that what I was trying to prove? Yep. And the reason was the what? Nope, not distributive. I'm writing the wrong thing, sorry. It is division. Okay, so we were given that the length of segment AC was 12. What you can't assume is that I know that AB plus BC equals AC. That's why we had to make that statement. Remember, I don't know anything about geometry, so you have to show me every step, not missing anything. Then we were able to replace what they're equal to because of substitution, and then we just used all of our other properties because then it turned into an algebraic proof, right? Yes, maybe. Kind of okay. It's proofs. They're difficult. Okay, but we will do enough of them that you will get the hang of it. Let's take a look at the next one. You should never have to think about the first step and the first reason, because what did I tell you it always is? Given. So fill in what it gives you. Yes, it's words. Yes, you have to write it. All right, what does it tell me? What am I given? All right, B is the midpoint of AC. And what's the reason? Given. Okay. All right, now we are trying to prove that x equals 6. So at some point, I need to be able to do like I did last problem where I substitute in their lengths. However, I'm not there yet. Flip back over. What does the definition of midpoint say? It said it divides it into 2 congruent segments, right? So if B is the midpoint of AC, according to the definition of midpoint, the definition of midpoint says that it divides it into 2 congruent segments. So tell me which 2 segments are congruent. Not yet. Not plugging in numbers. AB is congruent to BC. And the reason we know that is the definition of midpoint. So that's going to be my reason. Okay, because they told me B was the midpoint, The next thing I can say is what midpoint means. Midpoint means we divide it into two congruent segments. So therefore, I just told you which two segments were congruent. Can I substitute for congruence? Look back at the front. Was substitution a property of congruence or a property of equality? Of equality. So before I can substitute, I need to change my congruent statement from a congruent statement to an equality statement. Look back at the front where it said definition of congruent. If I told you that AB is congruent to BC, what should you be able to tell me next? The length of AB is equal to BC if you look at the front of your paper. Okay, look back up. I'm going to show you right here. Definition of congruence. If I'm told that two segments are congruent, then I can say that they are equal. You see that on your paper? Okay. So, because I was able to say that AB and BC were congruent, I can then say that they are equal, and that's the definition of, look back up. Definition of what? Congruence. So guess what my reason is going to be? Definition of congruence. Now, I'm going to abbreviate here. I'm going to just put the congruent symbol instead of write the word congruence because I'm lazy. Now, what do you think we should be able to do? Substitute, okay? What is AB equal to? 2x, okay? And what is BC equal to? And the reason we were able to do that is because we just did what? Substitution property. And you see I abbreviated, but I put SUBST. Enough to let me know that that's substitution, not subtraction. And if I were to solve the equation 2x equals x minus 6, how would I get to just x equals 6? Think of it. Yep. Exactly. In order to solve this for x, I need to move this x over here, so we would subtract it, right? 2x minus 1x is x. Those disappear, and what's left over here? 6. So my last statement is what I was trying to prove, that x equals 6. And how did I get there? What did I do? I subtract it. Again, if you're going to abbreviate, give me enough to know that it's subtraction, not substitution. So before you can put values in there, you have to tell me why the segments are either equal or, well, you have to tell me that they're equal, and sometimes before that you have to say that they are congruent based off of the properties.